Hi everyone, I'm Rhoda here with a JAC capsule on trigonometry. In this one, we're just going to look at how do you use the unit circle to come up with values of sine and cosine for special angles. So what's cosine of pi over 6? Or what's sine of negative 2 pi over 3? That's what we want to figure out, and we want to do it without looking at our notes and without looking at a calculator. This is important if you are going into the science program at John Abbott, where you won't have a calculator during quizzes and tests and all that kind of thing. If you're going into commerce or a social science program, then you will have a calculator, so maybe you don't need this video, up to you. Also, if you already know the answers to these questions, if you already have a good way of understanding the values on the unit circle, that's fantastic. I'm only going to be showing you one of many different ways to understand the unit circle. There's lots of different techniques. If you have one that works for you, keep using it. I'm just going to show you my favorite one. All right, so in front of us here, we have what you should recognize as the unit circle. And you have probably seen this in high school. Maybe you've tried to memorize the whole entire thing. I'm going to try to show you a different way to think about it. So the reason why we like the unit circle is it helps us keep track of the sine and cosine values at different angles, because at any point around the unit circle, the x and y coordinates of that point are equal to cosine and sine of this angle that I can draw right here. That's the angle from the positive x-axis going up until the point on my circle. That's what I'll call theta. So the x value at this point up here is always cosine of that angle. The y value is always sine. So if we know those points, then we know our sine and cosine values. That's true in any quadrant. So no matter what, the angle I'm talking about is the one that I get by starting at the positive x-axis and counting around counterclockwise. And then the x value is always cosine, the y value is always sine. This is if the angle is positive. We'll talk about negative angles as well. I want to use this now to answer questions like, what's cosine of pi over 6? Well, if you have the circle in front of you, you're just going to look for the angle 5 pi over 6. Here it is. And then you would say, well, cosine is the x value. So what's the x value at that point? It's negative root 3 over 2. That's the answer to my question. But what do I do if I don't have that unit circle in front of me? I'm going to be breaking it up into 2 steps. The first thing you need to do for any question like this is locate that angle on the unit circle. So we've got this unit circle, and it's got a lot of values on it. And it can be a little hard to keep track of. So what I would suggest to you is actually think of this unit circle as 2 different unit circles. So we'll have 2 cases. We separate this into 2 cases. The one where your angle is a multiple of pi over 4, or the case where your angle is a multiple of pi over 6. So instead of thinking about one big unit circle, think about these 2 separate versions of it, just in terms of figuring out where you're at on the circle. I'll tackle these one at a time. So first of all, what if you're asked about a multiple of pi over 4? Maybe I want to know what's sine of 5 pi over 4, what's cosine of negative 3 pi over 4, anything like that. The first thing I need to do is figure out where is that angle around the unit circle. So if I don't have a unit circle in front of me, then I'm going to just sketch one. It doesn't have to be very pretty. And I'm going to remember that if I go 1 full turn around the unit circle, that would be 360 degrees, or in radians, that would be 2 pi radians. That's 1 whole circle. This means that if I just consider the top half of the circle, it would be half of that. So the top half of my circle has an angle of pi radians. Well, pi over 4 would be a quarter of that. So if I take my top half of the circle and I divide it into 4 sections, so I'm just thinking about the top half of my circle, and I want to separate it into 4 equal wedges. In that case, each of those wedges that I just made has an angle of pi over 4. Well, that means I can just count around. So if I start at 0 and then I travel along the first wedge, then that will bring me to 1 pi over 4. If I keep going, I'll be at 2 pi over 4, then 3 pi over 4, and then 4 pi over 4. That makes sense because that's the same thing as pi. Okay, that's the top half, but I can do the same thing at the bottom because the bottom half of my circle would also be worth pi radians. Dividing it into 4, each wedge would be worth pi over 4. So divide the top and the bottom each into 4 equal slices. That will tell you that each slice is worth pi over 4 radians. And then you can just count around counterclockwise. So I get 5 pi over 4, then 6 pi over 4, which is the same thing as 3 pi over 2, then 7 pi over 4, and finally 8 pi over 4, which is the same thing as 2 pi. So that's how I would find my position on the unit circle. If I wanted to know what's sine of 5 pi over 4, I would just divide the top in half into 4 equal sections each, and I would count around. You start at 0 and you go counterclockwise. So 0, 1, 2, 3, 4, 5. Okay, 5 pi over 4 is located right here. Now, remember that anytime you have a positive angle, you're counting around the unit circle counterclockwise. But if the angle is negative, then you're going to count around the opposite way. You're going to go clockwise. So if I needed to locate the angle negative 3 pi over 4, I draw a quick circle, my x and y axis on it. And again, I'm going to count around in quarters of the top and the bottom. So I cut each one into 4 and I count. But this time, instead of counting counterclockwise, I count clockwise. So I can count 1, 2, 3, and these are kind of counting as negative pi over 4s. So this angle here would be negative 1 pi over 4, then negative 2 pi over 4, and then finally negative 3 pi over 4 is actually in the same spot as 5 pi over 4 was. So there's always going to be lots of different angles that end up in the same location on the unit circle. That's because those angles have the same sine and cosine values as each other, so we want them to land in the same spot. So that's great. All right, so this is a math video. There's no point watching a math video like it's a movie without a pencil and paper in front of you. It's always better to try things out yourself. That's how you're really going to retain it. So I have 3 angles for you here. 3 pi over 4, 7 pi over 4, negative pi over 4. Please pause this video and try to use what I just showed you to just draw where is each of those angles on the unit circle. I'll wait, come back when you're done. Welcome back. So here I've got my circle ready to go. I start at 0. I cut the top and the bottom each into 4 wedges. You don't have to necessarily draw the whole wedge. The point is just to cut it into sections so you can see. Now I count. So 0, 1, 2, 3. 3 pi over 4 is right here. Now I'll do 7 pi over 4. I just count some more. Starting back at the beginning, 0, 1, 2, 3, 4, 5, 6, 7. That means 7 pi over 4 is this angle here. Now, when it comes to a negative angle, I just go the other way. So starting at 0, count clockwise. This would be 1, 2, 3, 4, 5. Aha, so negative 5 pi over 4 is in the same spot as 3 pi over 4 right here. All right, so our first task is to take the angle that we're interested in and locate it on the unit circle, and we saw how to do that for multiples of pi over 4. Over on my left-hand side here, you can see that each of these wedges is worth pi over 4, and you just count around. The second case would be, what if my angle is something like 5 pi over 6 or 2 pi over 3? For that, we're going to do a second case where we break our unit circle up just a little bit differently, but it's the same basic principle. So you'll notice that pi over 6 and pi over 3 are grouped together in the same case. That is because if you are looking for an angle that's a multiple of pi over 3, you can always rewrite that as a multiple of pi over 6, and that's what I would suggest that you do. That way those two cases are really just one. So how do you find an angle on the unit circle if it's a multiple of pi over 6? Basic, same idea. We know that going around the circle one full time is 2 pi radians. So we know that going halfway around is pi radians. That means that the top half of the circle is worth 1 pi. If we take that 1 pi and divide it into 6 equal wedges, so I'm just drawing that out for myself. If I do that, each of them is going to be worth pi over 6 because there's 6 of them together making up 1 pi. So this would be 1 pi over 6, then 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. And of course, some of these fractions can be reduced if you want to. So I can get pi over 3 and 2 pi over 3 and 3 pi over 6 is of course pi over 2 and so on. But that's the basic idea. If I need to find an angle that's a multiple of pi over 6 or pi over 3, convert it to being over 6 and divide your top half and your bottom half into 6 equal wedges, count around, just like before. So my top half, I have 6 sections, each one is worth pi over 6, and I could do the same thing on the bottom. The bottom also has pi radians, so if I cut that into 6 regions, each one is worth pi over 6. So I can keep counting. I had 1 pi over 6, 2, 3, 4, 5. Pi is 6 pi over 6, so then I keep going 7, 8, 9, 10, 11, and then finally 2 pi is the same thing as 12 pi over 6. So that's how we're going to do it. And remember, if you have a negative angle, that's fine. You just count the other way around. So I bet you could already try to do this because it's the same thing that you've just seen me do with pi over 4. I'm going to give you 4 to try. Pause the video, come back when you're ready, and I'll do them too. So here's the solution. I've got my circle ready to go. This time I'm interested in multiples of pi over 6. So I'm going to be dividing the top and bottom half each into 6 equal wedges. Well, my wedges are never really equal, but that's okay. I do the best I can. So we've done that, and now we just count. I know that each of these wedges is worth pi over 6. So for 7 pi over 6, I start at 0. I go 1, 2, 3, 4, 5, 6, 7 pi over 6 is right here. By the way, if you want to save some time, you definitely can. You can say to yourself, well, I know that pi is 6 pi over 6. So why don't I just start there and then count one more to get to 7? That would be great. So that's the first one. Next one I'll do in pink, negative 5 pi over 6. Again, start at 0, but because it's negative, we're going to go clockwise. So count 1, 2, 3, 4, 5. Aha, it's in the exact same spot as 7 pi over 6. Great. Next one, 15 pi over 6. Oh, this one could actually be reduced, you might notice. If I divide the top and bottom by 3, I get 5 pi over 2. So you could do this one by counting out pi over 2s, but I'm going to do it with the method that we've been talking about. So 15 pi over 6, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or you could have skipped all that by saying, well, I know that when I get to 12, I'll be back at 2 pi. And you could have started from there. And then from the 12, you'd go 13, 14, 15. So 15 pi over 6 lands me right here, which makes sense because it's a multiple of pi over 2. So I've located 3 of my angles. The first one is in blue, second one is in pink, third one is in green. Let me do the last one, but it's getting pretty messy here. So I'm going to start with a new circle. So last one is 2 pi over 3. Before I can do 2 pi over 3, I'm going to convert it to a question about pi over 6. So we just convert that to pi over 6. Now I can draw out my sixths and count. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 is right here. So 4 pi over 6 is the same thing as 2 pi over 3, and I have located that. This is what I would suggest anytime you need to find a multiple of pi over 3 or pi over 6, just treat it as a pi over 6 question. That's our first task complete. We know how to locate our position on the unit circle. The next thing to do would be to figure out what is the value of sine or cosine at that position on the unit circle. So for that second part, continue on to the next video.